Question 9, similar to question 7, and I know I didn't do much of question 7, so we will do this one. I'm going to start with a cosec graph. Cosec graphs have this sort of shape here, the asymptote down here at 180 degrees, and then the other part of it there. Oh, and this one's in radians, so I put 2 pi, not 180 degrees, I'm going to put pi there. And we've got the other side of it here as well, so we've got the bottom bit there, an asymptote down here at minus pi, and the top part up there. And in the original cosec graph, this value here is 1, and this value down here is minus 1. Well, we need to stretch that. We need to times it by 5 to get the 5 cosec graph. And I don't want to redraw that, so all I'm going to do is I'm going to change that to a 5 and that to a minus 5. There you go, we stretch it times by 5. And the other thing we need to do is add 3 to it. So if I add 3 to the 5 there, that's going to give me an 8. And if I add 3 to the minus 5, that's going to give me a minus 2. Now, I suppose I should change my axis now to be a little bit lower, but at least it saves me having to draw the whole thing again. There's the graph that we were trying to draw. And the question then says, well, what value of k, if I draw a line across here at k, which values of k would have no solutions? And clearly k is somewhere between 8 and minus 2. You can't put an or equal here because then it would touch these parts here, and so there's no solutions when k is between 8 and minus 2.